smart civil engineers. I'm Engineer Masroor and you are watching Engineering Network YouTube channel. I'm back with another important topic. So in today's video, our topic is how to calculate the quantity of brickwork in superstructure of a house. Now in today's video, I will explain what is meant by superstructure and substructure of a house. And also I will find out the number of cement bags and the number of sand trucks used in the mortar of brickwork. Okay, so this is basically the sixth part of complete house estimation course. And also I am requesting you that please watch the complete house estimation course so that you can understand this video in a better way. You will find the complete course in the I button as well. So basically in today's video, I am going to show you how to calculate the quantity of brickwork in superstructure of a house. Now before I start this very important video, I have a request from you guys. So if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button. And also make sure to press the bell icon for more civil engineering videos. Okay, so our topic in today's video is how to calculate the quantity of brickwork in superstructure of a house. Now here first let me explain two terms in building construction. First is substructure and the second is the superstructure. Now what are these two terms? So basically the structure of building below the ground level is called the substructure of the building or house. And the example of the substructure is the foundation of the building. Okay. Next is the superstructure. So the structure above the ground level is called the superstructure of the building or house. And the superstructure of a building or house includes columns, brickwork, beams and slab of a building or house. Okay, so whenever you hear about substructure and superstructure, then you should know their meanings and also you should know that how to identify the substructure and superstructure in a house or building. Okay, now let's talk about the main topic of our today's video, which is how to calculate the quantity of brickwork in superstructure of a house. Now if you look at the video of 3D model of the house, you will see the empty spaces between the columns. Okay, so I have to fill these empty spaces with bricks or concrete blocks. So let's say that bricks are used for the empty spaces. Okay, now here the question is, how much bricks will be required in order to fill these empty spaces between columns, right? Well, for that, I have to calculate the volume of these empty spaces. And for the volume calculation, first I will calculate the length of these spaces, which are basically walls of the house. Okay? Now here, let's divide the walls of this house in three parts, so that we can calculate the quantity of brickwork in easy and simple way as possible, right? So if you look closely at the plan of the house, you can see that these three walls are provided in the same direction and with the same length. Okay, so let's name these three walls as W1. Then these two walls are also provided in the same direction and with the same length as well. So let's name these two walls as W2. And also let's name this partition wall as W3, whose length will be different from these two walls. Okay, so now I can say that I have three number of W1 walls, two number of W2 walls and one W3 wall, right? So this is how you can divide the walls of your house or building plan so that you can calculate the quantity without any difficulty and confusion, right? Now let's talk about the length of these three types of walls, which is W1, W2 and W3. Okay, so first let's start with the length of W1 wall. Now if you look closely to the plan of house, you will clearly see that the length of the living room is 36 feet, right? And if you watch the third part of the complete house estimation course, then you will remember that the size of this column right here is 15 inch by 12 inch, which means that the width of this column is 15 inch and the length of this column is 12 inch. Okay? Now here is the main point to learn, which is how to calculate the length of W1 wall. So what I will do here is, I will subtract the width of this column, which is 15 inch. And we know that 15 inch is equal to 1.25 feet from the length of the living room, which is 36 feet. Okay? And I will get the length of these two empty spaces, right? So the length of W1 wall is equal to 36 feet, which is the length of the living room, minus 1.25 feet, which is the width of this column. And the total length of W1 wall will become 34.75 feet. Okay? Next is the length of W2 wall. Now in W2 wall, you can see that I have another column of different size. And as I explained it in the third part of the complete house estimation course, that the size of this column is 12 inch by 15 inch, which means that 12 inch is the width of the column and 15 inch is the length of the column. Okay? And I'm telling you again that please watch the previous videos of complete house estimation course so that you can understand this video and also the coming videos of this course as well, right? So please watch it. Now for the length of W2 wall, again I will do the same trick here, which is I will subtract the length of this column, which is 15 inch, and we know that 15 inch is equal to 1.25 feet from the width of this room and the width of the living room. Okay? So the length of W2 wall is equal to width of this room, which is 14 feet, plus width of the living room, which is also 14 feet, minus length of this column, which is 1.25 feet. And the length of W2 wall will become 26.75 feet, right? Similarly, I will find out the length of W3 wall as well. So here the width of this room is 14 feet and the length of this column is 1.25 feet. So here I will subtract the half of the length of this column from the width of this room. Okay? So the length of W3 wall is equal to 14 feet minus half of the length of this column, which is 1.25 feet, divided by 2. And the length of W3 wall will become 13.375 feet. Okay? So now I have the length of W1, W2 and W3 walls of this house. And I hope that you will understand everything in this video up till now. But still, if you have any confusion, then please ask me in the comment section. Now let's start calculating the volumes of W1, W2 and W3 wall of this house. So at first is the quantity or volume of W1 wall. So the volume of W1 wall is equal to number of W1 wall multiplied by length multiplied by width multiplied by height. Here number of W1 wall in this house is 3. Length of W1 wall is 34.75 feet. Width of W1 wall is 9 inch. And we know that 9 inch is equal to 0.75 feet. And the height of these rooms and living room is 11 feet. In which 2 feet is the height of beam and slab. Okay? So basically the height of rooms and living room in this house is 9 feet. So the volume of W1 wall is equal to 3, which is the number of W1 walls, multiplied by 34.75 feet, which is the length of W1 wall, multiplied by 0.75 feet, which is the width of W1 wall, multiplied by 9 feet, which is the height of the room. And the total volume or quantity of brickwork in W1 wall will become 703.68 cubic feet. Okay. Next is the volume or quantity of W2 wall. So the volume or quantity of W2 wall is equal to number of W2 wall multiplied by length multiplied by width multiplied by height. Here in this house I have two number of W2 walls. Length of W2 wall is 26.75 feet. Width of W2 wall is 0.75 feet. And the height of W2 wall is 9 feet. Okay. So the volume of two W2 walls is equal to 2 multiplied by 26.75 feet multiplied by 0.75 feet multiplied by 9 feet. And the total volume of W2 walls will become 361.12 cubic feet. Similarly, I will find out the volume or quantity of W3 wall as well. So the volume or quantity of W3 wall is equal to number of W3 walls multiplied by length multiplied by width multiplied by height. Here I have got only one W3 wall right here. The length of this W3 wall is 13.375 feet. Width of the W3 wall is 0.75 feet. And the height of W3 wall is 9 feet. Okay. So the volume of W3 wall is equal to 1, which is the number of W3 walls in this house, multiplied by the length of W3 wall, which is 13.375 feet, multiplied by the width of W3 wall, which is 0.75 feet, multiplied by the height of W3 wall, which is 9 feet. And the total volume of W3 wall will become 90.28 cubic feet. Okay. So I have find out the volume of W1, W2 and W3 walls for this house. And for the quantity calculation of total brickwork in the superstructure of this house, I will need the total volume of brickwork in this house. Okay. So the total volume or quantity of brickwork in superstructure is equal to volume of brickwork in W1 wall, which is 703.68 cubic feet, plus volume of brickwork in W2 wall, which is 361.12 cubic feet, plus volume of brickwork in W3 wall, which is 90.28 cubic feet. Okay. And the total volume of brickwork for this house will become 1155 cubic feet, right? Now finally I have got the total volume or total brickwork for this house, which is 1155 cubic feet. Now in next step I have to deduct the volume of openings, right? Because if you look at the plan of the house, you can see that there are some kind of openings in the rooms and in the living room of this house. Okay. Now by openings, I actually means about doors, windows and ventilators. So what I will do here is, first I will calculate the total volume of these openings, and then I will subtract the total volume of openings from the total volume of brickwork in superstructure. And I will get the final volume of brickwork in superstructure for this house. Okay. And after that I will use that volume of brickwork in order to calculate the number of bricks and also the quantity of mortar as well. Right. So first let's find out the dimensions of these openings. So the dimension of door is 4 feet by 7 feet. The dimension of window is 4 feet by 6 feet. The dimension of ventilator is 1 feet by 1 feet. Okay. Now if you look at the plan and also at the 3D model of the house, you will clearly see that I have three number of doors in this house. One door is for the living room and the remaining two doors are for the two rooms. Okay. Also, I have got four number of windows in this house. Okay. Two windows are provided in the living room and one window for each room of this house. Right. And also I have got one ventilator in living room and two ventilators for both rooms. So the total number of ventilators in this house are 3, right? Now I will start calculating the volume of doors, windows and ventilators. So the volume of door is equal to numbers into length into width into height. Here is I told you that I have 3 number of doors in this house. The length of door is 4 feet. Width of door will be same as the width of the wall, which is 9 inch. And 9 inch is equal to 0.75 feet. And the height of door is 7 feet. Okay. So the volume of 3 doors is equal to 3 multiplied by 4 multiplied by 0.75 multiplied by 7. And the total volume of 3 doors will become 63 cubic feet. Okay. Next is the volume of windows. So the volume of window is equal to numbers into length into width into height. Here I have got 4 number of windows in this house. The length of window is 4 feet. Width of window will be same as the width of wall, which is 0.75 feet. And the height of window is 6 feet. Okay. So the volume of 4 windows is equal to 4 multiplied by 4 multiplied by 0.75 multiplied by 6. And the total volume of 4 windows will become 72 cubic feet. Next is the volume of ventilators. So the volume of ventilator is equal to number into length into width into height. Here in this house I have got 3 number of ventilators. The length of ventilator is 1 feet. Width of ventilator will be same as the width of the wall, which is 0.75 feet. And the height of ventilator is also 1 feet. So the volume of 3 ventilators is equal to 3 multiplied by 1 multiplied by 0.75 multiplied by 1. And the total volume of 3 ventilators will become 2.25 cubic feet. Okay. Now I have find out the volume of doors, windows and also ventilators. And now I want to calculate the total volume of these openings. Okay. So the total volume of openings is equal to volume of 3 doors, which is equal to 63 cubic feet, plus volume of 4 windows, which is equal to 72 cubic feet, plus volume of 3 ventilators, which is equal to 2.25 cubic feet. And the total volume of openings in this house will become 137.25 cubic feet. Okay. Now I have the volume of brickwork in superstructure with openings, which is equal to 1155 cubic feet. So the volume of brickwork in superstructure without openings is equal to 1155 minus 137.25, and the volume of brickwork will become 1017.75 cubic feet. So after deducting the volume of openings from the brickwork, I have got the final volume of brickwork in the superstructure, which is equal to 1017.75 cubic feet. Now finally I will calculate the total number of bricks in superstructure. Okay. Now as we know that in 1 cubic feet 13.5 bricks will be used. Okay. And I have already uploaded a detailed video about it, and you will find it on my YouTube channel and also in the I button as well. So the total number of bricks in superstructure is equal to volume of brickwork in superstructure, which is 1017.75 cubic feet, multiply by 13.5, and the total number of bricks in superstructure will become 13,800 bricks. Okay. Now for these 13,800 bricks, I will need mortar as well. So for the mortar, the mix ratio is 1:4 and the sum of ratio will be 5. Now basically in brickwork in a house or building, we use 30% mortar to the total volume of brickwork. Okay. So the quantity of mortar is equal to 30 divided by 100 multiplied by 1017.75 cubic feet, which is the volume of brickwork in superstructure. So the quantity or volume of mortar will become 305.325 cubic feet. Okay. Now this 305.325 cubic feet is actually the wet volume of mortar. So the dry volume of mortar is equal to 1.27 times the wet volume. And after putting the values, the dry volume of mortar will become 470.20 cubic feet. Now in this 470.20 cubic feet dry mortar, cement and sand will be used. Okay. So let's find out the volume or quantity of cement and sand in 470.20 cubic feet mortar. Okay. So the volume of cement is equal to 1, which is the ratio of cement, multiplied by the dry volume of mortar, which is 470.20 cubic feet, divided by 5, which is the sum of ratio. And the total volume of cement will become 94 cubic feet. Now we know that the volume of single cement bag is equal to 1.25 cubic feet. So the total number of cement bags is equal to volume of cement divided by volume of single cement bag, which is 1.25 cubic feet. And the total number of cement bags will become 76 bags, right? Next is the volume of sand. So the volume or quantity of sand is equal to 4, which is the ratio of sand, multiplied by 470.20 divided by 5. And the total volume of sand will become 376.16 cubic feet. Now let's say that volume of single truck is equal to 120 cubic feet. Okay. So the total number of sand trucks is equal to volume of sand, which is 376.16 cubic feet, divided by the volume of single truck, which is 120 cubic feet. And the total number of sand trucks will become 3.13 trucks. Okay. So this is how you can easily calculate the quantity of brickwork and superstructure of a house. Okay. Now in this particular video, I have find out the total volume of brickwork in superstructure. Also, I have calculated the total number of bricks and the total number of cement and sand used in the mortar of brickwork. Okay. Now as you can see, I have done all this hard work only to make you guys understand in the simplest possible way. And in the return, I am only asking for, if you find this video informative, then please like this video, share it with your friends, and also if you are new to my channel, then please click on the subscribe button and make sure to press the bell icon so that you will never miss a notification whenever I upload a new video. See you in the next video.